Hey there, year 10s. Just making a quick video here to help explain dividing algebraic terms. So I have a couple of examples here. In my first example, I've got 18x over 6. So there's a couple of ways you can think about this. I'm going to try to do both ways of thinking about it, just to kind of show you ways to think about this. One way is to think about it as, well, I know my multiplication tables, and I know both 18 and 6 are divisible by 6. So I can basically divide both of them by 6, because I can divide 6 by 6. So if I divide 6 by 6, that's going to become 1. So I can cancel out that 6. And if I divide 18 by 6, that's going to leave me with 3. So I can then write 3x over 1. That would leave me, you can even simplify that further as just 3x. You don't need to write over 1. Another way, if you're not as, if you don't know your multiplication tables, like right off by heart, the first thing I would do here is I'd notice that they're both even numbers. So I divide them both by 2. So 18 divided by 2 is 9. And then my x remains. And then 6 divided by 2 is 3. Next thing I would do is I would notice again that I have 3 and 9 as my two numbers, and I know that both 3 and 9 are both divisible by 3. I can divide 3 by 3 to get 1, and that's why I've crossed it out. And I can divide 9 by 3 to get 3. So I would then write my simplified answer as 9 divided by 3 is 3. And I include my x because it hasn't gone anywhere. And then 3 divided by 3 is 1. And that would be a way of thinking about it. Another way of kind of visualizing this, and this is kind of another way of thinking about it, is when you do these problems, you can think of it as, I'm trying to think of a way to kind of describe this easily. You can think of it as if you had 18x over 6. You can think of the ways of making 18 and making 6. So 18 is really a way of saying 18 is, you know, it's 2 times 3 times 3. So this goes way back to when you were probably in year 7, you would talk about factor trees. And so a factor tree of 18, take 18, you can break it into 2 and 9. And then 2 is a prime number, so you can't divide it down further. 9 is divisible into 3 and 3. So how do you make 18? 18 is made by saying 2 times 3 times 3. So that's how I got that. And then how can you make 6? Well, 6 is made by saying 2 times 3. Once you've kind of broken it into a factor tree, I'm not going to forget about my polynomial there, but once you've broken it into a factor tree, you can start canceling out. Canceling out works that if you have 3 over 3, that means it's equal to 1 whole. And that's why we can cancel things out. If I had 9 over 9, it'll also equal 1 whole. If I had x over x, it would also equal 1 whole. And that's a way of kind of thinking about a lot of what I've kind of just said. So when you divide it up into factor trees, what you can do is you can look at it this way. Well, my 2's, oops, was not the button I meant to press. You can say, well, 2 and 2 are common on the top of them, so they cancel out to form 1. 3 and 3 cancel out to form 1. And what am I left over with? Well, I'm left over with 3x, which is exactly the same answer I've gotten. So there's a couple ways to kind of approach these. Personally, I find this way to be a little bit hard because you got to know how to make the numbers. I find some of these a little bit easier. So, I give you 12a squared b divided by 8ab, and my 8ab is in brackets. So, what I would do is the first number is the numerator, the second number is the denominator. So I'm going to rewrite it as a fraction as my first step. So I'll write it as 12a squared b over 8ab. So I'm going to start out and look at this and say, all right, they're both even numbers. So I'm going to say, definitely they're both even numbers, so I'll divide them both by 2. So I'm going to divide the top by 2 and divide the bottom by 2. All right? So I'm going to divide the top number, bottom number by 2. So that's going to get me 6a squared b over 4ab. So still 2 even numbers. So I can again divide 6 by 2. So I'm going to take 6 and divide it by 2. I'm going to take 4 and divide it by 2 as well. So what's 6 divided by 2 equal to? 3. And what's 4 divided by 2 equal to? 2. And I feel bad I'm kind of writing it backwards. Like I feel that the way I've written this is kind of wonky. Really what I should have written it as is 12 divided by 2 and 8 divided by 2. And so writing like this, it should have 6 divided by 2. So like this, it should have said 4 divided by 2, just so it's proper math form. So then I've got my a squared b, and I have my ab. So this is where we can use some canceling out. If I have a b on the top and a b on the bottom, they can cancel out. I have an a in the bottom and an a squared on the top. This cancels one of my a's out on the top. So when I'm left over, here I have 3 over 2, and it's 3a over 2. So I'll let that kind of sink in for a second. I'll do one more, just for the sake of kind of giving you an example. The canceling out, you can do this all kind of together too. And I'll kind of do one more just to explain here. So let's just do one more. Let's go with 36xy squared over I'm just trying to think of something that would work well. 14 x y z. All right. So the first thing I'm going to do is I know that both 13 and 14 are even numbers, so I'll divide by 2 and divide by 2. 36 divided by 2 gets me to, this is where I wish I had done this ahead of time, not just made up in my head. That's 18. Ooh, so that's 18 over 7. The next thing I'm going to do is I'm going to look to see if there's any numbers I can cancel, or pronumerals I can cancel out. So I've got an x on the bottom, or to the top, and an x on the bottom. They can cancel out. So they've canceled out to form 1. Next, I've got a z all by itself on the bottom, so I can't cancel anything out. And I've got a y on the top that's squared, so I can cancel one of those y's out, and the second y is completely gone. So that's 18y 7z is what is left over. So that's kind of finished off. And I want to take a second and explain why y2 over y cancels out to make 1y. So again, think of this as y times y over y. Whenever you have something squared, that means it's multiplied by itself. So I said y times y. So now I cancel out, which leaves me with one single y left, which is why I had that. If you had this, if I had y to the power of 3 over y to the power of 2, you can think of that as y times y times y over y times y. Cancel those two out, cancel those two out. What are you left over with? And that would just be equal to y. So that's a way of thinking about how on earth does y squared over y equal just y. And that's kind of explained right there. So I hope that helps you guys out. I'm going to explain this also in our face-to-face Zoom that we're going to have as well. But I just thought I would spend some time and give you an example. Take care.